About a year ago, I built this huge marble pixel display, but in this video, I want to shrink it down and put it onto the back of a jacket that I can wear to the biggest science fair on earth, open source. The only problem, I'm leaving for the event in 8 days. That means I only have 192 hours to design, engineer, print, wire, code, and mount a working marble pixel display onto a piece of clothing. This is a rare opportunity for me to show my work to you guys in real life. Everything else just sits in this basement when it's done. So I really want this project to work. And I know I came up with this idea a little bit late, but was it too late? Let's find out. All right, here's what I'm thinking. So we got ourselves this jacket, and the marble pixel display is gonna be in the center. Above it, we're gonna have a binary distribution system that's gonna feed into the marble machine. Below it, there's gonna be 2 hoppers, one on each side. The display is gonna dump out into these hoppers, and then the hoppers are gonna pump the marbles back up to the top through a series of tubing into the distributor system. So there it is in all its glory. And I think the key here is that each of the modules are separate so the entire machine can flex on my back. But in order to make that happen, I need all of this tubing to be flexible. So that's the first thing I'm gonna try to tackle because it's crucial. And I have a cool idea that I wanna try to see if I can make the tubes work. Let's go try it out. Instead of running to Home Depot and buying a pre-existing flexible conduit, I want to try custom designing my own flexible tubes that I can 3D print. This way I can get tubes in the exact dimensions I need to fit the marbles, as well as perfectly connect between the modules. It's also a super fun design challenge, which we don't have time for, but we're just gonna do it anyways. Okay, so I have the tube designed, and the plan is to print the orange piece in TPU and then print the end pieces in PLA. But in the slicer, you can make it so the materials interlock. If I was printing it without the interlocking, TPU and PLA don't bond, so they would just peel apart. This allows me to have a tube with end pieces that I can connect to other pieces all as a single part. If I was going to the store and buying a hose, I would have to create adapters, and it just becomes a little bit more of a clunky design trying to bond adapters to a hose. This gives you a much more elegant way to do the same thing if it works. So let's print it out and see what happens. While that's printing, I can start laying out what this will look like on a jacket. This isn't the jacket I'm gonna use. I like this one too much, but it's good for now. The plan is to use binary gates to select the columns on the display. If I go with an 8x8 display, then I would only need 7 gates to select from the 8 columns, and everything will fit pretty easily on the jacket. But 11x11 would be so much better because it gives you more pixels to create images. Also, to save design time and space on the jacket, we're only going to be using black and white marbles, so I feel like we need 11x11 to keep up the cool factor of the project. But the main problem with 11x11 is it requires a whole other row of binary gates, which makes fitting everything on the jacket much trickier. I could also get away with a 12-column display in this configuration, but I want to keep one of the outlets free for color sorting, which we're going to come back to that. For the display itself, I have to decide between using clear tubes and this 3D printed frame. The tubes I used for my original marble pixel display are a little too big in diameter. You can see how the balls sort of stack up in a zigzag, so I'll have to source another option. The 3D printed frame, on the other hand, fits the marbles really well, but I do worry about losing my marbles as I'm walking around the event. To be absolutely sure that that doesn't happen, I think fully enclosed clear tubes will be much better, and I found this size polycarbonate tube, which I think is going to be perfect. Okay. Next up, I need to prototype a binary gate system. For our future project, I already designed this solenoid actuated gate. When the solenoid fires, the gate moves to one side. When it releases, the gate moves back to the other side. I decided to redesign it to use a cheap servo motor instead of the solenoid. This will make wiring and powering the whole display much easier later on, because a solenoid needs an electronic switch in order to be turned on with a microcontroller. But a servo could be powered by simply plugging the wire into a specialized servo driver. That means I only need 1 of these boards instead of 11 of these. The servo pops in here, connects to the gate through this gear, and after printing it all out, this is one binary gate assembled, and oh, that's so sick. Look at that. You go to one side. I need a marble. You go to one side. Boom. Other side. Boom. Simple, effective, easy to assemble. Now we need to connect 2 of them. Let's do it. I guess we need a tube, so let's see how that printed. Looks like the print was successful, but there are a couple problems. The first is the tube flexes really well in this direction, but it kinks when you bend it in this direction. I can solve this pretty easily by rotating every other cutout 90 degrees. This way it can flex on 2 planes. Nice. But the other bigger issue is looking inside, you can see that it's a bit of a mess, and this will definitely stop a marble from rolling through. To solve this, I tried tweaking the print settings to slow it down and tweaking the tube design to reduce the overhang as much as possible, but neither seemed to be working. Watching the print right when the overhang is happening, it becomes pretty obvious. The printer is knocking into the flexible thin tube wall, pushing it out of the way, which is causing the messy extrusions. I've been avoiding using support this whole time because I thought it'd be impossible to remove, but if TPU and PLA don't bond, the support should be pretty easy to remove, right? Let's go. Look at that. So sick. Flexes in this direction. This is a new hose, so it flexes a little bit in this direction as well. We put a marble in, boom, and then we can flip the direction, and boom. All right, that's a wrap on day one. I'm very happy with the progress that I made, but I've kind of gotten to that point in the project where I'm now starting to doubt if it's gonna work. Happens on every project. We just got there faster because we're just trying to get this done as fast as we can. So I'm just gonna keep pushing through it and see what happens. All right, see you in the morning. Day two, and check it out. We got the jacket. This is what we're gonna be using here. It's like a perfect thickness, and it was on sale. That's a huge win. This has made me feel a lot better about where the project is going right now. At this point, there's only one thing that I haven't fully conceptualized, which is the hopper, but I'm gonna get to that as soon as I'm done designing the display and the dropper. We're rating my chances. Like last night, I was like feeling like 5 out of 10. Now I'm kind of at like a 6.5. So we're going in the right direction here. Lots of more work to do, obviously. We're gonna keep going. Let's do it. For the display, I decided to go with these polycarbonate tubes that have a 15mm diameter and a 0.5mm wall thickness. To make the best image possible, I need all the tubes to be touching, which gives me a total of just 1mm between each tube. So I decided to forget the flexible routing tubes here in exchange for a rigid setup. I want to be absolutely sure that no balls ever get stuck in these tubes, which means that the final gates, routing tubes, and display area will be one single rigid piece. I'm not 100% sure how this is gonna end up being on the jacket. It might be just a little too rigid, but I ended up putting a piece of MDF in my test jacket, and it doesn't even look weird. Like it barely looks like there's a structure. I mean, obviously if I'm pulling, but if I'm just like walking around an event center, I'm okay with that. I'm okay with that. And I think it relieves some of the potential for it to not work. Yeah, I mean, this actually makes me feel like 100%. We're good. We're gonna make this work. This is what I needed right here. This is actually sick. Oh, I think that means we're at 7.5 out of 10 now. We're on the upslope of project success prediction 7.5. Let's go. It is still day two of this project. Different t-shirt. I went for a bike ride, ran into a branch on my neck. Yeah, I know. It's pretty bad, but I'll survive. And I wanted to show you something cool. Check this out. So I've decided I'm gonna print this entire thing in a single piece. And then I'm gonna use multi-material to connect the different pieces. It's hard to see here. You know, I'm gonna put it in the slicer and then I'll show you. Hold on. Everything that is blue is gonna be printed in PLA. Everything that is red is gonna be printed in TPU. And when we slice it, it's a big slice, so it's gonna take a little bit of time. But what I'm trying to show you is that when it slices, all the TPU and PLA are gonna be spliced together. It basically just comes off the bed pre-assembled and flexible. Pretty sick. I've never done anything like this, so I don't know how it's gonna work, but we're gonna find out. I hope it does work because I was like trying to figure out how to design in these screw holes, and I don't have to do that anymore, which is amazing. And then like I'd have to try to screw these into, all of it was just cumbersome and it was taking up a lot of space. And because I don't have to do that, I get to save space and I also don't have to do any assembly. This print right here is gonna take, it's not so bad, 11 hours. So if I run it now, we'll find out in the morning if it's gonna work. Let's do it. Oh, by the way, project, honestly, I think we're at kind of like an 8.5. I feel like it's gonna work now, and so I basically just gotta get it done. So 8.5, that could waver though. But right now, 8.5. Look at that. How sick is that? It's crazy. I wouldn't have dreamed of doing this even like a year ago before I had this Prusa XL. You can see that the flexing works perfectly. Like picture that on my back. It's perfect. Let's see if we can get this off the build plate. This is the last one. Boom. Look at that. That is so sick. So this is gonna go like, boom, right here. Okay, I've gotten the supports out of one of the branches here, so I'm gonna roll it in reverse just to see if it rolls. Ready? Go. Perfect. I think we're at a 9 out of 10. This is 9 out of 10. Like we're at peak project excitement before it's even done. I don't know if you can go higher than a 9 out of 10 before the project's done, because maybe 10 out of 10. I'm excited. This is sick. I gotta keep going. So next up is the hopper system, which will push the balls from the bottom up to the top of the jacket. To save time, I decided to repurpose the hopper system I designed for the bigger marble display, which used an auger to push the marbles out of the hopper while agitating the marbles above the auger to make sure that they don't jam. But instead of using the old hopper design exactly, I made everything smaller so it would fit better on a jacket. I also made the walls of the hopper quite low because I plan to connect the hopper to the display output later using some sort of flexible connection. I printed out the pieces, and after connecting a motor and plugging it in, you can see that it's working perfectly. And that concludes day 3, and also day 4 and 5, because I kind of forgot that I had a mini weekend vacation plan with my family. A little bit of an oversight, but it was worth it. It was a lot of fun, and I think we're gonna be okay. So now it is day 6. That means that I only have, including today, 3 days left to get this project done. Pretty much everything's designed now except for the distributors that will drop the balls from the pipes into the top of the gate system. So I'm gonna go design that now, and then I can start putting everything together, and I'll know for sure by the end of today if this is gonna work. So let's keep going. Let's get that done. Let's do it. I feel like every single time I'm talking to you guys, I'm like, well, let's keep going. But it is a 6-day project, so let's keep going. The tricky part when designing any marble distributor is trying to ensure that you only release a single marble at a time. In this case, the distributor needs to be compact and use a single servo. And after sketching out a simple concept, I jumped into CAD to turn it into a 3D object, which looks like it's going to work in the CAD, but the only way to know for sure is to print it out. While that's printing, I can cut out the 11 tubes I need for the display, as well as design the dump chute and get that print going. All right, the distributor is assembled, and yeah, this looks like it's gonna work. So I added the IR sensor for color detection, which works because the white balls reflect the IR fully while the black balls absorb it completely. And you can see that it's detecting the ball color really well, but this took the entire day to figure out. And now it's the end of day 6. Everything is designed, almost everything is printed. I have 2 more days to assemble the whole thing. Kind of hit that point where I realize how little time I have left. I mean, 2 days it's not a lot of days. The engineering guys are hopefully with me on this one. We'll find out tomorrow. Good night. It is day 7. This right here is the last part that I needed to start assembling this thing. Let's test it. Sick. I just love this stuff. Nice. So that means it's time to start building this thing. Let's do it. I rarely get the opportunity to show off one of my builds in real life. The things I make generally get relegated to my parents' basement after they're done. And don't get me wrong, the video sometimes gets seen by millions of people, which is a dream come true. But nothing really beats getting to share my work in person with the people who are as excited as me about these builds. People like you. This is why I'm so excited about making this project happen. It has to happen. Originally, I had planned to bring something much smaller to Open Sauce this year. The plan was always to make a simple wearable lift and drop marble run, but more like hat-sized, something I could design and build in a day. I feel like I'm a little cursed because when I do come up with an amazing idea for something with a deadline, it's always a little too late. But this idea was too good to ignore. It fits in with an engine easy theme of overcomplicated marble machines, but allows me to remain mobile, to hang out with those of you who have come far and wide to be part of this incredible event, to see the amazing things that you are all making, to be inspired by the people that I hope to inspire. That's why this project has to work. So I've been staring at this thing for like a half hour, trying to figure out how I'm gonna mount everything to the jacket. Some parts of the process are just like super easy. You can picture it all in your head. Most likely it's something that you've done before. Attaching a machine to a jacket, I've never done that before. So I don't really know the best way forward, but I think I have a plan. Step 1, laser cut a template and use a Sharpie to mark all the hole locations. Step 2, run to the store, really feeling this bag by the way, and grab a grommet kit with a hole punch. Step 3, scrap that entire plan and instead tape template to the inside of the jacket so you can just drill holes through the fabric. Step 4, run a screw through the inside plate, the fabric, and the outside plate right into the plastic parts. Step 5, repeat for the rest of the parts. It took a while to get to this point, but finally we can start cooking, and next up is adding all the display tubes and locking them down. And then came the scary step of drilling into the display tubes for the stopper system. After that, the stopper system went in, but then when I went to test it for the first time, It worked really well. Nice. Next came the distributor modules, and it was a little tricky to screw them in, but they did go in. And then finally, I added the dump chute. So that concludes day 7. I didn't get as far as I wanted to. I was planning to get the entire build done today, so I'm gonna place all my bets on tomorrow. I'm gonna wake up, I'm gonna get it done, and it's gonna be ready to go for Thursday. Let's hope. I'll see you tomorrow. It is the last day, day 8, and the last thing I have to do is figure out how to attach the output from the display to the top of the funnel. And I was planning to use these Ziploc bags, but I have absolutely no idea how I'm gonna do this. Hopefully this doesn't take too long to figure out. I think I'm just gonna try something, and if it doesn't work, it doesn't work. I saw a video that said that you can heat up a knife, use it to cut a plastic bag, and it stitches the cuts together. And after testing it, it seems to work. So I drew out the general shape of what I'm looking for on the bag, heated up the knife, and just kind of sent it. It wasn't the most confidence-inducing seam. Remember, if it breaks, I lose my marbles. So I tried using the side of the hot knife to weld the seams together, but it kept melting away the parts of the bag that I was trying to weld. If only there was a tool in my shop that heats up and I can carefully control the temperature. Wait a second. The MVT award goes to the soldering iron. Hooray. And I eventually landed on this technique of dotting the bag, which creates this sturdy seam. But now there's Sharpie lines on the bag, not looking that nice. So for round 2, I used a piece of paper to trace out the shape, placed the bag over the paper, and dabbed away. After cutting the shape from outside the seam, I had the flexible hopper connector of my dreams. Finally, I used some double-sided VHB tape to attach each side to the outlet of the display. New skill unlocked, I guess. I wish that I could say that this whole process happened quickly, but in the end, this whole thing took about 6 hours. And in hindsight, it might not have been the best way to do this. Honestly, I'm still not sure what the best way to do this would have been. Let me know if you have any better ideas. And after adding VHB tape to the inside of the hopper walls, I carefully pressed in the bottom of the bag and repeated on the other side, hoping that this is enough to keep the bag stuck in place. But it's done, and done is better. It's something. It's something. And I'm getting hit with that wall of like exhaustion. Like I was just looking back at some of the footage and I can't believe that was yesterday. I was doing some of this stuff yesterday. I'm like, holy moly, what a trip. The aesthetics have come together how I've envisioned it. But now I have to like wire the whole thing up, do all the coding. I mean, it's already like afternoon, day 8. I'm running out of time. Oh my God. I think this is the first time in the project where I'm feeling a little bit stressed. Now we've come this far, like there's no going back. I should probably try this on before I keep going, right? It's actually like not that heavy considering what's on this jacket. Huh? Eh? With the build finally finished, it is time to wire the whole thing, and I didn't get any footage of this because I was truly feeling the time crunch, but this is how it looks. The main goal here is to make sure that the whole thing functions, and then I can worry about the rest in San Fran. Okay, each function is working individually, so here's a quick rundown. To get the marbles to the top of the jacket, these hopper motors turn on. Once a ball enters the sensor, the corresponding hopper motor turns off. I can set the gates to any of the 11 columns, and there's this truth table that tells the code which gates to move. So for gate 6, for example, the code leads to this gate configuration. Then I can drop a white ball into column 6. But if both sensors have black balls, the gates flip to the dump chute, drop a black ball, then pump another ball into the sensors, and then it flips back to the current column. Boom, white ball, column 6. Finally, to dump out the balls, this motor turns the rack and pinion, pulling the stopper back and allowing the balls to release. All right, so I filled up the whole thing manually. Let's see what happens when we try to dump the whole display at the same time. 3, 2, 1, go. Wow, that actually worked. That worked really well. At this point, it was getting pretty late, and I decided that actually figuring out how to make images on this thing was California Jay's problem. I piled on a bunch of bubble wrap, collected some tools I thought I might need, and gave the suitcase a final safety shake. Good to go. Okay, bye. I made it to San Francisco, and so did the jacket, which means that I did not lose my marbles on that flight. I don't know what I was doing last night when I packed this thing up. I don't even know what it looks like in that suitcase. Let's open it up and find out. Kind of nervous. Here it goes. Uh-oh. Uh-oh. Okay, it looks fine, but we gotta plug it in and see. So it made it in one piece, but there's still a bit of a battle ahead trying to get it to turn individual motor movements into images. So I just never know if it's the code, is it the wiring, is it the mechanics? I'm gonna install the drivers. Let's go. I'm gonna run it for the first time, and I don't think it's gonna work, but we're just gonna try it and see what happens. So, ready? 3, 2, 1, go. Okay. I don't even know what just happened.
That's not what you want.
Fill sensors. No, that one's not. See how it's pushing there? This battle through integration hell continued for the rest of the day Thursday and late into Friday. There was an issue with the ball sticking to the tape in the hoppers that required some emergency surgery, but after all the troubleshooting, it was starting to sort of produce images. I decided to manually code in 10 different images that I can pick from at random. I did get my buddy Ryder from @RyderCalmDown to put together this app, which would allow anyone to make an image for the machine. Unfortunately, I ran out of time to get the app working, but I will be coming back to this in the future, so stay tuned for that. Make sure to check out Ryder's channel to see some really cool and creative engineering projects. I linked it below. I did use Ryder's app to help me make the manual images for the machine, and literally on the morning of open source day 1, I finally got this working. It's crazy what can be achieved in a week, but it's actually the result of a lifetime of accumulated knowledge built through trying to learn something new every day. A fun way to learn new things every day is through this video's sponsor, Brilliant. Projects like these require more than just knowledge. Problem solving is key. Brilliant helps build your critical thinking skills through problem solving, not memorizing. So while you're building real knowledge on specific topics, you're also becoming a better thinker. Each lesson is filled with hands-on problem solving that lets you play with concepts, which has proven to be 6 times more effective than watching lecture videos. And with a perfect mix of engaging problems and daily encouragement, Brilliant makes it easy to create a habit of learning every day by keeping you motivated. There's this really interesting thinking in code course, which I'm going to go back to so I can optimize this grid filling algorithm. Filling line by line is definitely not the most optimal way to do this, so there's a gap in my knowledge, but I can easily fill that with Brilliant. Plus, all the content on Brilliant has been crafted by an award-winning team of researchers from Stanford, MIT, Caltech, Microsoft, Google, and more. To learn for free on Brilliant, go to brilliant.org/engineeasy, scan the QR code on screen, or click the link in the description. This link will also give you 20% off an annual premium subscription, which gives you unlimited daily access to everything on Brilliant. I'm so happy I went with 11 by 11 on the display. I love how this image looks. But the last thing we need to check before heading to the event. Perfect. Let's go to open source. This is my 3rd year at OpenSauce, and somehow it gets better every time. I hit my goal of building a mobile marble pixel display, and seeing it come to life in such a creative space was incredibly fulfilling. I will say, I didn't totally think through the part where the machine was on my back, so every time someone stopped to watch it run, it was a little tricky to talk, but even then, the reactions, the conversations, the encouragement, it all reminded me of why I love doing this. OpenSauce isn't just an event, it's a community of builders, thinkers, and endlessly curious people who genuinely want to see each other succeed. Every conversation sparked new perspectives, every project inspired new ideas, and every person I met reminded me just how powerful it is to share the love for making stuff with others. I already can't wait to come back next year. Thank you so much for watching this video. I'll see you in the next one.